Hello, this is Mr. Koi. So continuing on with our talks about graphs, we're really going to be going into a slope review. So the things that you should know by the end of this, you should be able to define slope in both words and equations. After that, you will need to be able to tell the difference between a positive and a negative slope. So tell the difference between a positive and negative slope. And last but not least, actually find the slope of a graph. This will be with linear lines though. Slope of a graph. Alright, so we got these four figures, and they are all on slopes. As you might think, slope comes from what we'd say, the slope of a hill. Alright, you can tell if a hill slopes up or slopes down. So just intuitively, I want you to look at these. We could write a graph on them, but that's not what I want to do. So for each of these figures, draw them in your notebook. You could draw them prettier, you can just draw a circle. Does not matter. But here's what I want you to do. Write which ones are positive and which ones are negative. So which ones are positive or negative? Alright. And then which slope is the smallest? So, go ahead, draw that pause, think about it. So which ones are positive and negative, and which slope is the smallest? So first things I really want you to look at, like which ones are positive, which ones are negative. You can see right here, in this one, he's going uphill, right? So if you put your coordinate planes in this, you can see, if you're used to graphing, now this is actually going to be a positive slope. From here, this one you can't quite tell, but I actually was going for a 0, completely flat, neither positive or negative. This one kind of looks like he's falling. It's going to be our negative slope. Alright, he's going downhill. This one, barely holding on, clinging, it's also going to be a negative slope. So one way to think about which are positive and which are negative, positive are which the guys are going uphill. Negative would be looking at it like it's a downhill. As you go to the right, you're going downhill. And then which slope is the smallest? By smallest, I didn't mean absolute value, so if you pick the most negative one, which would be this one, that's fine. But I meant by which one had the lowest absolute value slope. That would be the slope where it's 0. It's neither going up or going down. It is staying completely flat. Alright, so we're now doing the definition part of this video. Please draw this on your paper, and off to the side somewhere, start writing ways that you have defined slope. Just make a small list of them, and then we'll go over the definitions that I would like you to know. Alright, so hopefully you have a couple definitions off the side of your paper. So the one you most likely wrote down, because it's very common in your math class to hear this, is the rise over the run. We also have, for example, when we're talking about our hills, how steep is it, right? How steep is the slope? Additionally, you may have also heard this in math class. I really like delta, so it's delta y, so change in y, over delta x, or change in x. Another way to write this is y2, or y final, because that's what delta is, y final minus y initial, so y2 minus y1 over x2 minus x1. And also, we can think of this as how quickly something changes. This might have been called a rate in your math class, or in chemistry when you talked about reaction rates. How quickly something changes. And we are actually going to focus initially on this last one and then get into the actual calculations of it. So we will be using this one first. It's actually talking, what is happening to our graph, or what's happening to our car per se, if we're talking about, I'm sorry, I spelled quickly wrong. I can't write the C. There we go. So, what changes are happening. We call this rate. Alright, so the way I like to think about slope is really how quickly the y, or whatever is the y, changes with whatever the x is. So today and on Friday we worked on our position versus time graphs. So let's say we start at some position at time 0 and we increase our position. So we can look at our slope and see how quickly. So right here, right, as time goes on, we're really not changing our position very much. But over here, it starts changing faster. So we can say that, it's getting steeper as time goes on, right? So our slope is increasing. So it's changing faster as time goes on. So our slope gets higher here. Now, what if we had a different graph? Let's do money. Money is something we care about. So over time, we have some amount of money. Say you save up a lot of money, and then you start spending it really quickly. And let's end on a happy note here. We're in the positives. But right here, right, our slope, if this was a hill, our little guy was standing on it, he started going downhill. Your slope is going down, and it's going down pretty quickly. So as time goes on, you're losing money very fast. Right about here, we kind of hit rock bottom, decided to start saving again, and as time goes on, we now get to increase our money. So our money ends up being positive in the end. But you actually go into debt. You have negative money right here. Alright, so we're going to practice with this graph here. I know it's a little blurry, but I did write in the numbers to make sure you can see it. So we want to start figuring out the slope for each of these areas. Now you'll notice there's definitely more than one slope here. All hills here are not the same. So we're going to label this slope A, slope B, slope C, and slope D. Now to find out the slope, so let's start with slope A. So we have slope A. So we need to find out the change in y over the change in x. So we need to know how far our y changes over how far our x changes. We started here at 0, so that's really easy to figure out for our change in y. That would be the final minus the initial, but our initial was 0, so it's going to be pretty easy. And then same thing with our x. We went over here to 10, So it's going to be our final 10 minus the initial, which was 0. So if you know anything minus 0, that doesn't matter. We don't care. So it's going to be 60 over 10. So 60 divided by 10 is going to give us a slope of 6. Now if I had units, say this was meters and this was seconds, that would be 60 meters over 10 seconds, so we get meters per second. That looks familiar to you. Good. We will talk more about what that means. So I want you to try to do the same for slope B, C, and D. Figure out what the slope of each of those is, pause the video, and try them yourself. Alright, for B, we pick our 2 points that we need to go between, say these two. Well, if we look at our rise, it's 0. We haven't risen at all. We haven't really moved from that spot. So that's going to be 0 over our run, which is half the distance between 10 and 20, which would give us a count of 5. So it's 0 meters over 5 seconds. So we haven't gone anywhere. Our slope here is just 0. Now if we look at C, you know, it's a little trickier. I'll talk why in a minute. So pick 2 points on C. I picked these two because it's easy. One of them ends at 0, which is nice. So one of the things is when we talk about getting the rise over the run, C actually is falling, right? It's not rising at all. So you need to now make sure that you show that it's falling. So remember, always put its final in front of its initial. So its final y over here is going to be 0 minus the initial y, which is up at 60. So you can see how this is going to get us a negative here. And that would also be in meters over the change in x. So our x final is 30 minus our initial here is 15. So we're going to get negative 60 over 15, and this gives us negative 4. If you weren't sure, you can plug that into your calculator. Now on to D, our last slope. Again, I'm going to pick what I find to be the easiest slopes, or easiest points to get my slope from. These 2 points here. So we can see we are rising again. So we go from here at negative 40 up to 0. So another way to think about that is final minus initial. But remember, we're already at negative 40. So it'll be 0, our final position, minus our initial position, which is a negative 40. So we are doing a double subtraction here, which, if you recall from math, it makes this positive. So that's just going to be a normal 40, a positive 40, over our change in time. So this is 40, 50, so this is going to end up being 55. So it went from 40 to 55, so we can do 55, the final, minus the initial, which is 40. So that gives us a change in 15. So 40 over 15, this will give you about 2.7. There are some decimals in there. I rounded it off. I do not want to see all of your decimals. Do please round it. So that is for our finding our slope. Recap, we went over, the definition of slope. What are the different definitions of slope? What does a positive and a negative slope look like? And then finally, how exactly do you find the slope? So finding the slope and talking about the definition is what we are going to be working on a bit more tomorrow, as well as talking about position and time graphs.